This week on the show, we have new ZFS features landing in FreeBSD. We have MapStack for OpenBSD. We show you how to write safer C code with Clang's address sanitizer. We talk about Michael W. Lucas on sponsor gifts, cover the TCP Black Box Recorder, and a Dell disk system hacking in this week's episode of BSD Now. BSD Now, episode 240, TCP Black Box Recording, recorded itself on the 30th of March 2018. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Glad you tuned into this week's episode of BSD Now. We have not only Alan in a ZFS shirt, we also have headlines about ZFS. So there's a number of upstream ZFS features landing in FreeBSD or already have landed in FreeBSD this week. So why don't you talk about this, Alan, for a while?
Yeah, so we'll have more on next week's show as well, because there was just too much to fit it all in 1 week. But lots of interesting stuff. So our first one here is from Alexander Botan, who merged it into FreeBSD from upstream. But it's bug number 9188, increase the size of the debuff cache to reduce indirect block decompression, which may sound slightly confusing, but what it is we have the compressed arc, and to avoid decompressing, what the compressed arc does is if the block of data is compressed on the disk, it stays compressed when we cache it in RAM. This allows us to get, the 2 or 3 or more times compression we get on disk in memory, so we can store more data in the cache. And then so the downside to this is if you access a file 4 times when it was in the cache, you actually decompress it 4 times, whereas before you decompressed it when you read it off disk once and stored it in memory, and then you could read it many times without having to decompress it. But LZ4 is so fast, and having a higher cache hit ratio because you can fit more data in RAM is better. So to mitigate this, especially for blocks that you read a lot, like metadata, so say like the metadata for a certain directory that's full of files and you're accessing all the time, like on a web server or a mail server or whatever, there's a debuff cache. So we keep a small cache of file blocks that we decompress a lot so that we won't have to decompress them many times a second. So this,
the cache is
also a block, we keep this little tiny cache of uncompressed blocks so that if we read the same block a second time within the same second or whatever, we don't decompress it a second time. So when compressed arc was added, we allowed up to 25% of your CPU time to be used to decompress indirect blocks. So these are the kind of ZFS is like this tree of blocks that gets bigger and bigger, and indirect ones are all the kind of the middle bits. So to reduce this decompression cost, we would like to increase the size of the debuff cache so that more indirect blocks can be stored uncompressed. If we are caching enough large files with, say, block size equals 8K, the indirect blocks are 1/64th as much memory as the data blocks, assuming they have the same compression ratio, and it's entirely possible the metadata will have a much better compression ratio. So we suggest making the debuff cache 1/32nd of all memory instead of 1/64th. So this will set aside a little bit more of the arc for this debuff cache, and by keeping more of this data uncompressed, we won't have to decompress it as much, and we'll get better throughput.
Okay, I'm all for that.
So that in this scenario, we'll be able to keep all of the indirect blocks for a bunch of blocks in the debuff cache. So basically, because of the way it was sized previously, you could keep a bunch of data in there, but all of the metadata for that data as well wouldn't quite all fit. So by making the debuff cache a little bit bigger, we can fit the most active data and all of its metadata together. And we want it to be more than the 1/64th that the indirect blocks would use, because we need to cache all the other stuff in the debuff cache as well. So in real-world workloads, this won't help as dramatically as in the example above, but we think it's worth it because the risk of decreasing performance is low. it's most likely going to make an improvement, not a
Making it worse.
yeah, it's not going to make it worse. The potential negative performance impact is that we slightly reduce the size of the arc by about 3%. So it might hurt your cache hit ratio a tiny bit, but it's going to make the cache hits you get much better.
Okay, and this one was developed by George Wilson as the original author.
Yes,
and a couple of people, including you.
Yeah, so he wrote
reviewed.
the compressed arc feature and this improvement to it. So he wrote compressed arc and the debuff cache, so it made sense for him to be the one to improve it.
Okay, that's polishing going on. Okay, very nice. And you reviewed that parts
Yes,
of it?
It was a relatively small change, so it was easy to review.
Okay, that's something people can look out for or look forward to even.
That's in FreeBSD head and is available basically in 12 current as of, if I refresh this, the time.
Yeah, a couple
of 43 hours ago it went into head, so it's very fresh.
People are already compiling their kernels.
Yeah.
All right, the next one.
Yes, this one's a very nice one. So this is the Zoopool checkpoint that we talked about back in like almost a year ago when it was introduced. But it's finally been upstreamed and then from upstream down into FreeBSD. So the idea of storage pool checkpoints or Zpool checkpoints deals with being able to roll back a whole pool. It's basically a pool-wide snapshot. They're a little special because you can only have one. And while it exists, no data is freed or overwritten. Everything is kept. So if you make one of these and keep it, you will very quickly run out of space. But anyway, it can be thought of as a pool-wide snapshot or a version of extreme rewind that doesn't corrupt your data. Basically, it remembers the entire state of the pool at a point that it's taken. So the Uber block that then points to every other block down that tree I described earlier is copied and kept somewhere. And because the other point of when one of these checkpoints exists, we never free or overwrite data. That means that the old version of everything as it existed when the checkpoint was taken still exists. Whereas normally you can roll back to one of those older Uber blocks, but maybe some of the data has been overwritten or something. This way, it's not. So anyway, its generic use case is an administrator that is about to perform a set of destructive actions as part of, or actions to ZFS. Delphix invented this feature for use during appliance upgrades. Right? During the upgrade, they're going to rename some data sets and delete some stuff and all this, and they needed a way to be able to just undo it all if it didn't work. Or, if you're about to delete something and you're not sure you're going to do it right or whatever, taking the checkpoint first, super helpful. Or you're going to do a pool operation like adding more drives. And as some people have learned from painful experience, if you don't do this right, you can't undo it. Well, now you can.
And if you
take the checkpoint and you add the drives and you accidentally say add your 2 SSDs as separate drives at the end of the pool instead of adding them as a mirror, or add your 6 new drives that were going to be a RAID Z as 6 non-redundant drives, now you're in a boatload of trouble. But you just export the pool, import with the flag to roll back to this checkpoint, and it's all undone as if it never happened. You be careful though, because when you roll back, everything you did since then didn't happen. As if it never existed. It's time travel. Once you go back, you can never get back to that same future. You've changed things.
Yeah, but it's better in some situations than restoring the whole pool if things totally wrong.
Unlike a regular file system snapshot, you can't undo a ZFS destroy with a snapshot. But with a checkpoint, you can. But yes, the general idea is you take a checkpoint, you do some stuff, you make sure it all went fine, and then you can get rid of the checkpoint. Or if it didn't work, export the pool, import from the checkpoint, go back, everything's okay.
Very nice. Good to have. Yeah.
But remember, you can only have one, and
Yeah.
you don't want to keep it around very long because nothing can be, no space can be reused or freed or overwritten while one exists.
Okay. I'll have to make some more experiences with that, but it's good to know that
Yes.
this exists.
Yeah. Ideally, it's something you hope you never need, but
And always when you do pool changes, use the N flag to simulate how the pool will look like. But yeah, in case things you
yes. So
already made.
yes. Before you do most of these operations, if you add the -n flag, like ZFS destroy -vn or zpool add -n, it will print out what it was going to do without actually doing it. But it's nice to be able to have the,
The save option with the checkpoint.
Yeah.
Okay, but there's more.
So there's also 8484, implement aggregate sum and use for arc counters. So in pursuit of improving performance on multi-core systems, we should implement fanned out counters and use them to improve the performance of some of the arc statistics. These stats are updated extremely frequently and can consume a significant amount of CPU time. So ZFS keeps track of like every read and write from the arc and like your cache hit ratio and all these things. And doing that can be kind of expensive, especially with the locking. So I think the version of this keeps per CPU counters for some of this, and then there's a thread that goes wrong in the background and aggregates the numbers from all those counters and stuffs them into the one you read, so that the stats might be slightly delayed. I think milliseconds, but you get a lot better performance. You don't spend a bunch of your CPU time just keeping track of how busy ZFS is, leaving more CPU time free for you to keep ZFS busy.
In other ways. Okay. Yeah, that seems like also good to have in the system.
And then one of my little commits made it in. So this is 9321. Arc alone compressed buff can increment the arc lone bytes counter by the wrong value. So I discovered this while working on the Z standard compression work. In particular, if you disable the compressed arc feature and then do a ZFS replication with the compression feature, so you end up receiving blocks on the receiver side, you're getting the block and it's already compressed. It assumed that you only needed the compressed amount of space in memory. But actually, because you're going to uncompress it, because you don't have compressed arc on the receiver, you're going to need the logical size, not the physical size.
Oh, sure, yeah.
Yeah, so the function arc loan compressed buff, which basically loans out a buffer from the arc to userland for it to write the data into, it increments a counter, the arc loan bytes, by the physical size unconditionally. So no matter what, it would use the physical size, which pre-compressed arc was fine because the physical size was probably the same as the logical size. But with compressed arc, it means the compressed size, not the actual size. In the case of ZFS compressed arc enabled equals 0, when the buff is returned via ZFS return buff, it actually has a check. If the buff was compressed, then arc lone bytes is decremented by the logical size instead of the physical size. So the problem came when you receive this block that's, 128K, but it has a physical size of only 60K because it was compressed. We would increase the counter by 60K. Then when we would get the buffer back, we would decrement the counter and be like, oh, this block isn't compressed, so let's reduce the counter by 128K. And suddenly the counter is negative, and that triggers an assertion and panic.
Yeah, and we don't want to have that.
You can't loan people negative bytes.
Yeah, sure.
So
Okay.
switch to using, there's a special function, a macro called arc buff size, which does the check whether, is this block compressed and do we have compression enabled and all that. So by using that, in all the cases, instead of manually picking physical size or logical size, we always get the right numbers and it doesn't crash. It's possible this would actually trigger memory corruption because you were claiming you were loading somebody 60 bytes and then they were writing 128K into it. So that could have been a problem as well.
That doesn't fit. Yeah. So that was uncovered by your work in the Z standard.
Yeah. So while I was working on Z standard, there was a special case in Z standard to deal with. Matt pointed out that if you have compressed arc turned off, but you have an L2 arc, when you write the data to the L2 arc, you have to compress it the same way as it is compressed on disk, because the L2 arc uses the same checksum to avoid having to have two different checksums to make the L2 arc take less RAM. And with Z standard, we have these different compression levels. And we're not storing them the old-fashioned way because we don't want to take up 20 compression types just to store it. And as it turns out, Z standard's adding negative levels of compression now, which are faster. And that means there's actually going to be 25 or more different levels. And so we really don't want to be eating up, there's only room for 30 or 60 compression levels in ZFS. And we don't want to use up 30 of those for Z standard. So I had to come up with a different way of passing the compression level through so we could recompress it properly for the L2 arc. And while testing it, I noticed that when I did a ZFS receive from my other machine, and I happened to use the -C flag to keep it compressed because it was the source code for the... So while debugging on my laptop, I sent a copy of the source code from my development machine to my laptop. And I wanted it to ship compressed because it's all source code. So it was compressed like 4:1. So it would take a lot less time over the network. And it would crash. And eventually I figured it out. And it turns out it wasn't my fault. It was a bug because almost nobody disables compressed arc because it's an amazing feature.
Yeah, of course.
But
and it didn't, and wasn't uncovered before.
And you combine it with the ZFS compression set and receive, which didn't exist until after compressed arc. And kind of depended on it, and probably they didn't test that way. Anyway, I found the bug and I fixed it, and it's been upstreamed. And that's my second. I think that's my second real upstream commit, because the other one was kind of
excellent.
It was if you do the capital H flag to exclude the headers and change all the separators, instead of lining up human columns, it would just use hard tabs, so you can easily like awk or cut out the output. That wasn't working for the ZFS holds command. There was some missing logic, so I added that.
See, small things like that can make a big difference.
But yes, hopefully I will land a really big feature soon. But this is one of the little fixes I got in.
Yeah. And it wasn't discovered because gzip doesn't have negative compression levels. That's
it wasn't that. So for gzip, all 9 of the compression levels are actually different compression types in ZFS.
Okay.
Right. So it actually takes up 9 slots. LZ4 takes 1, gzip takes 9, LZJB takes 1, etc. Which seemed fine because they're like, well, we originally they had 128 of them, or 126 usable slots, but then they sold the top bit for something else, so that cut it down, and they cut it, and then Z standard comes along with its 19 or 22 levels, and then actually there's no bound on the negative level. Eventually, you just get to not compressing. But I think we're going to support about the first 5 negative levels or so, which actually make it get faster and faster till it's almost as fast as LZ4. Really interesting.
I can't wait to get that. It's just so nice to hear about this compression level.
With all that, we're looking at 25 or more compression levels, and we don't want to use up all the slots in the enum. So Z standard only takes 1 because... So in the block pointer, we just have this is compressed with Z standard. Because when you decompress it, you don't have to know which of the levels it was compressed with, right? When you run gzip and you compress something, -1 or -5, -6, -9, whatever, it doesn't matter when you unzip it. Same with Z standard. And so that was working perfectly. And we didn't have to, we only had to know the compression level when we were writing, and we could get it from the datasets property. And then this L2 arc thing came up, and it's like, when we're moving the data from the arc to the L2 arc, we have to recompress it, and we have to know what the compression level was. So I had to do all this stuff to keep track of it.
Wow, excellent. That's
yes,
certainly a nice work.
So now, anyway, there's a bunch of different stuff, and maybe I can describe the design of the Z standard work on another day.
When it's coming
George
out,
Wilson,
we'll do a special episode.
George Wilson's going to review
Just
it,
for that.
and hopefully he
Real
doesn't
soon
find any
now.
problems with it. But I will describe the version after I fix any problems he points out.
Yeah, it takes as long as it takes. It's ready when it's ready. Okay, so yeah, stay tuned for more next week.
Optimistic me would like to have it ready, or maybe in FreeBSD for the ZFS user conference in 2 and a bit weeks.
Oh, okay. No pressure.
That might be optimistic. I'm very, very strongly hoping to have it committed before I present about it at BSDCan. So that when I tell the story of the year and a half of effort to get it done, there's a happy ending.
Yep. Okay. We'll
and they lived happily ever after with lots of compression.
Yeah. Excellent. Yeah. Again, we'll cover more features landing in FreeBSD from ZFS next week, so stay tuned. And we should jump into our next item, which is map_stack for OpenBSD. I think we covered this also a couple of times in earlier episodes. So basically, this is over at OpenBSD from Theo Derat, mentioning in the OpenBSD-tech list that almost 2 decades ago, they started work on write or execute.
Yes, sir. WX or X.
Yeah, XOR. The concept was simple. Pages that are writable should not be executable, and vice versa. Pages that are executable should not be writable. We applied this concept object by object, trying to separate objects with different qualities to different pages. The first one we handled was the signal trampoline at the top of the stack. We just kept making changes in the same vein. Eventually, write X or X. Is that the way to pronounce it? Yeah. Okay.
It's just WX or X.
Okay. WX or X came to some of our kernel address space also. This also led to a push for creating more .ro data objects, just read-only data. The fundamental concept is that an object should only have the permissions necessary and any other operation should fault. The only permission separations we have are kernel versus userland, and then read, write, and execute. How about we add another new permission? This is not a hardware permission, but a software permission. It is opportunistically enforced by the kernel. The permission is map_stack. If you want to use memory as a stack, you must mmap it with that flag bit. The kernel does so automatically for the stack region of a processor's stack. 2 other types of stack occur, thread stacks and alternate signal stacks. Those are handled in clever ways. When a system call happens, we check if the stack pointer register points to such a page. If it doesn't, the program is killed. We have tightened the ABI. You may no longer point your stack register at non-stack memory. You'll be killed. The checking code is, what is this? Machine independent?
Machine independent, yep. So it's the same code applies to, ARM and x86 and Spark and MIPS, etc.
All the architectures OpenBSD runs on, yeah. Cool. We can also perform this check on standard synchronous traps, for instance, page faults. We cannot yet perform it at a standard interrupt yet, but they are working on that as well. So this checking code has been written for i36, AMD64, and MIPS64. Others are being worked on. The check is fast. We're comparing 5 variables for bounds. If that fast path check fails, we call a slower check with the required locking and checks if the process that other stacks which may be invalid or valid in the region on the stack pointer location, for instance, threads. So since page permissions are generally done on page boundaries, there's a caveat that thread and alt stacks must now be page sized and page aligned so that we can enforce the map_stack attribute correctly. It is possible that a few ports need some massaging to satisfy the condition, but we haven't found any which break yet. This syslog_r has been added so that we can identify these failure cases. And also the faulting cases are quite verbose for now, so to help identify the programs we need to repair. So this work has been done with Stefan Kempf, which is Stefan at openbsd.org, and you can find more information after that, which includes the patch. So definitely try this out on OpenBSD. It gives you more security that's already there.
Yep.
Very cool. It's actually something that other BSDs should also look at because it's not too OpenBSD specific.
Yeah. Be interesting to see what the memory usage overhead of having to page align the stacks are, but I imagine it's quite small, so the granularity is 4 kilobytes, so you're probably not going to have that much. And I don't know how many stacks you actually have on a running system. I can't imagine it's more than a couple thousand. And so even if you waste 2 pages, it's like, 8 megabytes of memory.
More or less doesn't hurt anyone.
And you probably don't have thousands of stacks unless you're running like Firefox or something.
Oh yeah, okay. So look out for that coming to OpenBSD. And you should also check out our sponsor for this week. The first one is IX Systems. Head over to ixsystems.com and check out what they have to offer. Alan, you did a couple of orders from them recently, I hear.
Yes. I had lots of fun installing those 32 12 terabyte disks. That was lots of fun, actually. So we have a primary and a backup machine, and the backup was actually a bit smaller. It had originally 24 5 terabyte drives, whereas the primary had 36 6 terabyte drives. 36. When we needed to grow those systems, we bought the shelves, which we talked about November-ish, I think. So we bought these 4U special chassis that are just 24 disks in the front and 20 disks in the back, and then a SAS cable that connects it to the server. So for those, we put 24 more 6 terabyte drives in the front. We put 12 in the front of each originally, and then we added 12 more 6 terabyte drives. And then we were like, wow, we're having to do that kind of often. Our customer is filling us up with data. We should maybe consider bigger hard drives because we're down to 20 free slots in the chassis already. So we decided to go with the 12 terabyte hard drives because they're actually about the same cost per terabyte as the 10 terabyte drives. And really not much of a premium over the 6 terabyte drives. And would actually be cheaper than having to buy another shelf, plus have to deal with getting more rack space to fit it all. So we put 10 more 12 terabyte drives in each of those, leaving 10 slots at the back of each of those chassis free for more 12 terabytes in a couple months. But the problem is the backup is smaller, right? Because it actually only had 24 times 5 terabytes versus 36 times 6 terabytes of data. So the backup couldn't hold all the data anymore. So to catch it up, so the reason we bought 32 of the 12 terabyte drives was 10 each for the 2 different sites to grow the pools the regular way, but then 12 to replace drives in the backup server. So what we did was put 10 of the 12 replacement 12 terabyte drives in the slots at the back of that shelf. And then we did zpool replace on 10 of the 12 5 terabyte drives we wanted to remove.
Yeah. That's easy to do in the ZFS.
We could take out 10 of the 5 terabyte drives and put in the 2 remaining 12s and do the last 2 zpool replaces on the other drives. And then we exported the pool and reshuffled all the drives around and brought it back up. Or we could have done it one at a time, moving them, but it was easier to just shut the machine down for a couple of minutes. It is the backup as it is, right?
Sure. And the disks arrive in the enclosures already?
Yes, so the disks come in the hot swap trays already, and all the little screws are done up nicely, so we could just slide them in. It was great. But the nice thing with ZFS is because we had the extra drive slots available, we could do all of this online. We only had to do 2 resilvers instead of 12 if we'd done one drive at a time, if we, hadn't had the slots. And we still maintained the N+2 redundancy the entire time, because when you do a zpool replace while both the new drive and the old drive are still working, and connected,
Yeah.
you don't lose any redundancy.
Sure. That's what you want to have. And you during the serval, the storage is still available. It's maybe a bit
Yes.
slower, but it's still available.
Well, and you can rate limit that stuff as well. Yeah. So, yeah, it worked out very nice. And it was great because we could just tell IX, it's for the, like when we were getting the extra disks, it's like, yeah, those are for the shelf we bought recently. But then I could also be like, 12 of those drives are actually for this server that we bought like 2 years ago. And they double checked and made sure that they would use the right drive brackets. Because depending on the chassis, it might be different hot swap trays. And we want to make sure we get, if the drives come in hot swap trays, that's great. If they're the right trays for your chassis. But they are. And so because every system is custom built at IX, they have a history of all, like I actually get a spreadsheet of all the machines I've ever bought from them. And I can be like, yeah, I need more drives for that one and this one. And it's just, they make the whole process super easy, even when it's upgrading a server instead of buying a new one. It just.
And as Alan mentioned,
experience.
yeah. Well, and you mentioned that one of the people who works for IX Systems, Alexander Moten, imported the ZFS features we just covered, and that's a good combination. That's because IX Systems is using ZFS or OpenZFS more specifically in many of its storage servers and employs people to work on this. And of course, they commit that to FreeBSD as well. So there's a win-win for both. And,
yes, all the commits we covered earlier in the episode were committed by Alexander Moten, who works for IX.
Yeah, so if you're interested in getting a system that's built to your open source needs, tailor-made, whether it's storage as expensive or it needs a lot of CPUs or specific memory configuration, then give them a call and they will recommend you or especially tailor-build you a system that's specifically built for your needs. All right, on with the show. We have some information about writing safer C, which everyone should look at with the Clang address sanitizer.
So for a bit of background, the developers in this article were looking at improving their password strength algorithm, and they decided to go with the industry standard tool, ZXCVBN. I don't know why it's called that. Probably
Never heard
it's
about
supposed
that.
to be random. From the people at Dropbox. So for their web front end, they use the default JavaScript library. But for the mobile and desktop applications, they wanted to use the C implementation. So they bootstrapped it all together, and it was pretty quick, and they were happy. And they toyed around with some sample passwords. So I decided to run it through the test suite we had for our previous password strength evaluator. The test generates a large number of random passwords according to different rules and expects the strength to be given as a valid range. But the test runner kept crashing with segmentation faults. So it turns out the library has a lot of buffer overflow cases, which are usually harmless, but eventually they add up and crash your program if you run the evaluator function too many times. I started fixing these case by case, but reading someone else's algorithm to track down tiny memory errors got old really fast. So needed a tool to help. So enter the Clang address sanitizer. Called KSAN.
And what it's doing is sanitizing the addresses, basically.
Well, it sanity checks the addresses before it reads and so on. So the address sanitizer is a fast memory error detector. It consists of a compiler instrumentation module, which basically adds information to the code as it's compiled, and a runtime library that can use that data. The tool can detect the following types of bugs: out of bounds accesses to heap, stack, or global memory. So if you read past the end of an array or anything like that, it will detect it. It can also detect use after free, use after return, so you've left the scope of that function and are still accessing the memory or whatever, use after scope, double free, invalid free, or memory leaks, although that support is only experimental. So that covers a large portion of all the crashes that you've ever faced in C. So what's the impact on performance? Typically, the slowdown introduced by the address sanitizer is about 2x. So your program will take twice as long to run. But the idea is you mostly do this for like the testing suite, not the binary you ship to customers or use in
Not the
production.
production.
Yeah, but while running your tests, having them go a little slower and actually detect the problems is a big win.
Yeah, during
And
development
so,
phase.
yeah, that's perfectly acceptable in debugging contexts where usually you're slowing it down a lot more than that. And especially if it saves you hours of painful looking for the needle in the corrupt stack. So to try it out, they wrote a simple little program here. You can see it just declares a static string, hello world, and then allocates 13 bytes of memory and copies it in. And then it sets the null byte at the end. But you see, what we're doing here is actually invalid, right? The string, or the variable stir, is 13 bytes long. So the valid indexes are 0 through 12. So accessing 13 is actually accessing after the end of that memory allocation.
Yep. Everyone who's dealt with arrays before had this transposed error.
If you compile and run this program, it actually works perfectly fine. Because likely, when you did the malloc, you got a whole page of memory and it doesn't happen to be anything using after, and there isn't some other variable stuffed directly after it that you're going to overwrite currently. But it shouldn't work. Or should it? And, it's undefined behavior to access after the end of the array there. So when we're assigning 0 to the character index 13, we're writing after the end. Now, if we recompile it with -f sanitize equals address, now if we output that, you see they have a little screenshot here of what it looks like.
Yeah, colors to the world.
Yeah. It tells you that you've made a mistake and actually does a printout of the memory showing you where this has happened. So we see address sanitizer, a heap buffer overflow at some address at program counter X, blah, 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 blah. So the address sanitizer found a heap overflow at that address, which is a seemingly valid address, and it prints out the program counter, base pointer, stack pointer, etc. And when we break it down a little bit more, we see a write of size 1 at that address by thread 0, and it actually goes down to tell us it was actually on line 10 of our clang-ascend.c, and we look that up, that's us writing past the end of the array.
Yeah, that's the one. And it even
tells us this is located 0 bytes to the right of the 13-byte region that you allocated over here. So you realized, oh, I'm actually writing 1 byte after the end of my allocation.
Mm-hmm.
This is that part is definitely one of my favorite indications. In addition to telling which line of the code failed and where the memory the failure happened, you get a complete description of the closest allocated region of memory, which is probably the region you were trying to access when things went off the rails, right?
Mm.
If you're 1 byte too early or 1 byte too late, knowing what you were 1 too early or too late from helps you figure out where in the code that's probably coming from. Then they go into a deeper example, actually using LLDB as you go through it, so that instead of crashing, you can actually interactively poke around and single step through the program and see what's going on. So there's all that.
Yeah, it's good to have in every C programmer's toolbox.
Yeah, and then you can see using LLDB, you can dump out all the thread info as JSON and do all kinds of stuff with it.
Hmm. Yeah, that's good to have. I mean, the whole LLVM suite is good, but each individual tool is also very, very helpful.
Yeah. So, like it says, we get the exact stack trace at the time this memory or this address in memory was allocated. In a more complex program, we would get the history of all of the times the address was allocated and then deallocated, making it a very powerful tool to understand cryptic memory bugs. Because the weirdness you're seeing might not be from the most recent allocation. It might have been that you allocated the memory, wrote some data into it, freed only part of it or something, messed something up, and then later on reused it or something. Or you forgot the null terminator and it was fine, except for when the previous person using this allocation of memory wrote something other than zeros at the end, and then your string ran off the end of the stack or whatever. Anyway, so their conclusion here is back to our practical case. How do we put the address sanitizer to good use? I simply ran the test suite compiled with the Sanitizer and hooked it up to LLDB. Sure enough, it stopped on every line that would have caused a crash. It turns out there were many cases where the ZXCVBN-C implementation wrote past the end of allocated buffers on the heap and on the stack. I fixed those cases in the C library and ran the test again, and look, no seg faults in sight.
Ooh, excellent.
So they said they've used memory tools in the past, but they were usually unwieldy or put such a toll on performance that they were useless in real-life cases. Clang's address sanitizer turned out to be detailed, reliable, and surprisingly easy to use. They've also heard of miracles of Valgrind, but they're developing on a Mac, and macOS hardly supports it and makes it a real pain to use on your laptop. So I know Valgrind. I've used Valgrind on FreeBSD before and found it very helpful. But I know that it had some problems with certain API changes and stuff that were made. And, if Clang works better, I'm happy to have that. Or to have both tools in your toolbox is better, right?
Right. What the one finds maybe finds the other.
Mm-hmm. Or even just getting the two different descriptions of the problem can help make it make sense to you. Anyway, coupling with Clang's static analyzer, the address sanitizer is going to become a mandatory stop for evaluating code quality. It's also going to be the first tool I grab when facing confusing memory issues. There are many more cases where I could use early failure and memory history to debug my code. For example, if a program crashes when accessing members of a deallocated object, we could easily trace the event that caused that object to be deallocated. Find where the free was, because obviously maybe we don't want to free it just yet. Saving hours of adding and reading logs to retrace what happened, right? You can think of cases where the address sanitizer would be useful, then they would like comments on their blog.
Yeah, so try out the examples and get a bit more familiar with the address sanitizers. You will find them. They are a good tool to have.
Yep.
So, time for News Roundup. In this episode, we have one item called On Sponsor Gifts. This is over at Michael W. Lucas' blog. And what we can see here is a stack of books. Yes, this is SSH Mastery, 2nd edition. So he writes, last week, Liz and I converted this pile of books.
Giant pile of books.
Into this, a little less smaller pile of mail-ready packages, I guess.
Yeah, they're basically padded envelopes with books and other things in them.
So what this is about is note the little stack of customs form off the side. It's like I've learned a lesson from standing at the post office counter filling out those stupid forms. Sponsors should get their books soon. This seems like an apropos moment to talk about what I do for print sponsors. I say I sent them a gift, but what does that really mean? The obvious thing to ship them is a copy of the book I've written. Flat out selling print books online has tax implications though. Sponsors might have guessed that they'd get a copy of the book, but I shipped them the hardcover, which isn't my usual practice. That's because I sent sponsors a gift. As it is a gift, I get to choose what I sent. I want to send them something nice to encourage them to sponsor another book. It makes no sense for me to send a sponsor singing Wedgie O'Graham. Well, maybe there's a couple sponsors. You know who you are. The poor bastards who bought into my scammer, sponsored my Untitled book, have no idea what's coming. As of right now, their sensible guesses are woefully incomplete. Future books, they might get a copy of the book. They might get book plus something. They might just get the something. Folks who sponsored a Jails book might get a cake with a file in it. Who knows? If it's a gift, it's my job to make that gift worthwhile and to amuse myself, because otherwise, what's the point? So yeah, thank you, Michael, for doing this to sponsors. I look forward to picking up my sponsor gift at BSD Can, because I told him, don't ship this to Germany, just take it along with you on your BSD Can travel this year, so I can be surprised.
Because I've got room for more stuff.
Oh yeah, because now that I'm reporting this, it's nice so I can forget about it until BSD Can, and then I'm like totally surprised that he has a book for me.
Yeah, you might want to avoid being surprised by a Lucas.
Sure,
It's
yeah,
happened to me a few
surprises.
times, and
But yeah, I'll
suddenly
take
there
my
was a
chances.
French version of the book, or there was Liz made me some very nice gifts, actually. Thank you,
Oh
Liz.
yeah, very nice. Yeah. So
Of course,
look out for
it's
more
because she
sponsoring
understands
opportunities.
the pain of putting up with Michael.
I guess she is trained now. Yeah. So yeah, if Michael is putting out a request for sponsorship for a future book, I strongly suggest you should think about giving him a bit of money up front to have your name in the book when it appears. So everyone who reads that book and opens it and reads through the acknowledgement section, you are listed there for
Yeah,
the
well,
eternity.
it depends if you happen to want a cake with sharp pieces of metal in it.
Yeah, in case you are in a jail when you get to buy the jail book or have sponsored a jail book, which is a nice way of getting your file to get out of jail. Um, well,
No
yeah,
jail
we'll see.
escapes. Not over here.
But yeah, thank you, Michael, and we look forward to more books from coming from you. All right,
So
what's
then we have another FreeBSD commit, not ZFS related this time, from FreeBSD committer Jonathan T. Looney. He's added the TCP Black Box Recorder, which was a feature we discussed at BSD Can and BSD Cam last year. The TCP Black Box Recorder allows you to capture events on a TCP connection into a ring buffer. It stores metadata with the event. It optionally stores the TCP header associated with the event, even if the event associated with a packet, and also optionally stores information on the sockets. So it supports setting a log ID on a TCP connection and using this to correlate multiple connections that share a common log ID. So you can actually tag data as it comes in and then keep related tags together so you can extract this information and actually correlate separate connections too. So you
okay?
can log connections in a couple of different modes. If you're doing a coordinated test with a particular connection, you can test the system and put it in mode 4, which is just continuous dump. Or if you want to monitor just for errors, you can put it in mode 1, which is the ring buffer, and dump all the ring buffer associated with a specific connection ID whenever we get an error signal on that connection ID. You can set a default mode that is will be applied to a particular ratio of incoming connections, and you can also manually set to a mode using a socket option. So the idea here is I don't know when I'm going to want information. So if you're Netflix and you're doing 100 gigabits a second out of the box, you can't TCP dump.
That's impossible at this scale. At this scale, yeah.
Yeah. So you could set it and say, keep a small ring buffer on every connection. And then if we run into an error, we can grab that ring buffer and dump it. And now we'll just have caught the stuff leading up to and the error while not actually having to store everything. Or I'm just doing a test on a router and I just want to see, this particular connection come in or a load balancer or something and grab it that way. Or you're Netflix and you just set it on a certain ratio. So just, 1 in every 10,000 connections, I want to log the data so I can get a sampling of what's going on.
Yep, for statistics and other interesting analysis purposes.
So this commit introduces just the basic probes for dealing with the connections or whatever. Randall Stewart has added quite an abundance of probes to his TCP development work, and he plans to commit those soon, although this part had to go in first. There are user space programs which they plan to add to ports. These read the data from the log device and output PCAPNG files, so you actually be able to analyze it in TCP dump or Wireshark. And then they'll let you analyze the data and the metadata. So even the data added by the kernel that isn't normally part of the packet will be in a format that you'll be able to analyze with your packet analyzer.
Excellent. I can also see this good for finding out problems with firewalls where you have too restrictive rule sets and stuff.
There's generally enough logging in firewalls already where you can log rejected packets and so on.
True. Yeah.
But yeah, having this little ring buffer black box means you can use it for anything. And more importantly, you can correlate connection. So if you're writing a load balancer, right, you receive an incoming connection, and then in response to that, you make an outgoing connection. But by using the socket option stuff, you can actually tag both of those connections as being, a certain session for the load balancer. And suddenly you can deal with both of those flows. You can extract both of those flows and know that they're related.
Yeah, and have the
and that makes a big
association.
Difference.
Yeah, I think networking people will like that very much. So,
But even just, a varnish cache, just being able to associate the incoming connection with the connection to the back end may actually make quite a useful feature.
okay, very nice. Yeah, so people should check that out and look for more coming from Netflix and Randall in this specific area. Yep.
Speaking of load balancers and performance, time for DigitalOcean. If you head over to digitalocean.com and sign up, you can get a FreeBSD machine running in the cloud in like less than 55 seconds. Then you can either use their load balancer feature or use their floating IPs feature and run a varnish in front of multiple droplets to deal with your website. So you can scale up your website. You can add additional droplets when you need them. Since you pay for them only hourly, you can turn them off when you don't need them. And they have a great API. So on the front end one that's running varnish, and maybe you get one with a bit more RAM for that. Like if you look down here in the flexible droplets, you can get one with lots of RAM and not much CPU because varnish doesn't need a lot of CPU. And that will receive all the incoming connections for your website and then pass them out to however many backends you have. Then it can detect, hey, all the backends are pretty busy right now because the site's busy. Let's spin up some more backends and use them. And then, the site's not busy anymore. Let's spin down some of those backends. And since you only pay hourly, you only pay for what you use.
Sure. And you might be sharing your little droplet with multiple team members, maybe the web developer or other networking people or a database administrator. So you can create a team on DigitalOcean to manage that little droplet or the droplets you might have. So there's one account for multiple teams. It has security features.
Because I have a personal account. I need to be able to access the Scale Engine account. I need to access the an account for another group of people I work with, and a fourth one, and I can do that with one login. I don't have to have multiple logins. I can easily just I make sure that all my personal droplets go on my credit card. Sorry.
What did you just drop down here? Droplet?
My droplets go on my credit card. The company's droplets go on the company's credit card, and my employees can't see the company credit card.
Yeah, because you can separate the billing permissions to only look at certain
the Teams feature is even just useful. I run the mail server that does more than just my mail. So maybe I need somebody else to be able to access it while I'm in Japan and I'm going to be out of the time zone and only awake when they're asleep and so on. Being able to have someone else be able to go in there to be able to just reboot a droplet or whatever, super helpful.
Yep. So when you sign up and start your first droplet, make sure to use our coupon code FreeBSD Now, which gives you a $10 credit that will allow you to try it out for quite some time before the real billing starts. And that way you can explore the DigitalOcean environment on our bill, basically, for the first $10.
Yeah. With the hourly billing, if you only use it for a little bit, it only costs you that. If you're just using it to mess around with, I just want a remote FreeBSD machine I can play with, and I'm only going to play with it, 4 hours a day, 2 days a week, then you only pay for 8 hours a week.
Yeah, that's possible in DigitalOcean. Okay, that's we have another news item for this section called Out of the Way KDE 4. So from the picture here, you can already see that there's a bit of a rough or rude moving unwillingly. So it says here that KDE 4 has been rudely moved aside on FreeBSD. It's still installed. Use X11/KDE ports or package and should update.
That's the change. Instead of being called KDE, it's called the KDE 4. You need a 4 now.
Right.
Well, you said without the 4, and that's the
Oh,
part that
sorry.
doesn't work anymore.
Exactly. Yeah. So
Yes, so they
KDE4, that's the
renamed.
one.
Yeah, they renamed KDE to KDE4 so that very soon they'll be able to add KDE5 as an option.
Hmm.
So if
So yeah,
you already have KDE4, when you do package upgrade, the names of everything will change, but everything will be fine. Everything will still
the
work. It'll be okay.
the ports people or the KDE team on FreeBSD specifically put a lot of effort into this, making it seamless for the user as much as possible.
Mm-hmm.
Yeah, so this is another step towards adding modern KDE with Plasma 5 and applications to the official FreeBSD ports tree. This has taken a long time for administrative reasons, getting all the bits lined up so that people sticking with KDE4, which right now should be everyone include using KDE from official ports and packages on FreeBSD, so that they don't end up with a broken desktop, which no one wants, especially with KDE. They don't want that. But now that everything Qt4 and KDE libs 4 based has been moved aside by suffixing it with -KDE4, we use the unsuffixed names free to indicate the latest and greatest from upstream.
Yes, I remember when Qt5, I think, first came out, the name of VLC changed. So because I had KDE installed, when I tried to package install VLC, it's like, well, I'm going to uninstall KDE and all the Qt4 stuff and install Qt4 and VLC. I'm like, that's not what I want. And a little searching found that if I do package install VLC-Qt4, I would get something that would work with KDE. And so they've done that with all the KDE and Qt4 stuff. So now you'll be able to choose KDE4 or KDE5.
Mm-hmm. Yeah, so KDE4 users will see a lot of packages moving around and being renamed, of course, as Alan mentioned. But curiously, the KDE4 desktop depends on Qt5 and KDE5 frameworks 5. And it has quite for some time already, because the Oxygen icons are shared with KDE frameworks, but primarily because FileLite was updated to the modern KDE applications version some time ago. And the KDE version had some serious bugs, although it doesn't, the blog post.
KDE4 version.
KDE4, yeah, right.
When you're differentiating 4 and 5, you have to actually say the numbers as it's written
important
on the page.
Yeah, sure. So that one had some serious bugs, the KDE4 version, but that's not sure yet what they were.
Yeah, so previously they were forced to give the KDE5 version of FileLite to both, or to KDE4, and so that they would be able to do it for 5. Now they have the option of giving KDE4 users the buggy version back, but I doubt that was what will happen.
Mm-hmm. So from here on, they've got the following things lined up. Qt 5.10 is being worked on, except for a web engine. It would slow down and update way too much because Plasma is going to want Qt 5.10 soon. There's a CMake 3.11, which is in the RC stage, so that it's being lined up. And the KDE 5 import branch of KDE, FreeBSD's copy on the FreeBSD ports tree, also known as Area 51, is being prepped and polished for big SVN commits that will add all the new bits. So they've been saying real soon now for years, but things are realer sooner now. Okay. Yeah, it takes a lot of work. I know that the KDE guys put as much work in this as possible to make it available as soon as possible on FreeBSD. And thanks for the efforts.
And their biggest problem is that every time they almost get there, some component moves up a version and then it gets more complicated.
Yeah, if you want to offer your help, then you can contact them at, is it FreeBSD KDE at FreeBSD.org, or is it just KDE?
I think they're both the same, but FreeBSD-KDE at FreeBSD.org is the team's alias, and you can reach them by email there.
Mm. Okay, very good to have KDE updated soon. And look forward to that one.
Yep. So next we have a slightly older blog post, but about the Dell FS12-NV7, which is a 2U server that's great to build a FreeNAS. So it covers dealing with the storage controller, which PERC6 is basically just an LSI Mega RAID 1078, so can be flashed to just behave as an HBA. Or you can add your own SAS card, and walk through that a little bit and talk about the machine. basically, the Dell FS12-NV7 is a quite popular machine that is getting quite a bit older nowadays. And so lots of them are available from various, computer recyclers, like on eBay and so on. So if you're looking for a relatively, I guess, medium-sized but professional-grade hardware to build a FreeNAS with, this is a good option. Although the hardware's a little on the old side as far as power efficiency, and in particular, the RAID controller is, I would aim for something slightly newer.
And noise levels, I guess.
I don't know what the noise levels are like, but definitely you want to aim for something like the LSI 9207 or 9211 instead of the old 1078.
Yep. So if you are
say,
market,
yeah, they talk a bit about the SAS card and how to set that up. Moving on to the front of the case, there's 12 metal drive slots with the backplane behind it. Dell makes machines with either backplanes or expanders. A backplane with a 1-to-1 SAS channel, drive connectors, and expanders takes one SAS channel and multiplexes out to multiple drives. So depending on which one you get, you'll either, if you have 12 drives, you'll actually have 3 SATA ports, and you'll need a controller that can handle 12 drives. Whereas, for example, the 9211-8i only handles 8 internal drives. But if it has an expander, all on one cable, you can handle like up to 128 drives or something. So you watch out for that, because you might end up needing a bigger controller or a second controller to connect all the drives. I think actually when I built the backup machine I mentioned earlier, because I wanted to use SATA drives back then, I went without an expander. So 24 drives in groups of 4 meant I actually had to buy 3 LSI controllers, each one doing 8 drives. And then I added the external shelf. So that machine actually has 4 LSI controllers.
Yeah, planning ahead is important when buying servers.
So they talk about that a bit more. In particular, going with LSI controller because of the best OS support for FreeBSD and so on. And I talk about basically removing the perk and plugging in your modern 9211 or whatever, and running the cables and connecting it to the backplane, all that. They talk about a bunch of the different places and things to get it all connected. They also talk about using SATA drives and mixing those in there. And they say, well, removing the backplane looks tricky, but it isn't really once you look a bit closer. Once you take out the fans, which are held in place with rubber blocks, undo a couple of screws, it just lifts and slides out, and you can put in the expander or non-expander version, depending on what you want. And you also look at the power supply. It has a special connector into the backplane so that you can power all the drives, and you might have to rewire that a little bit.
Okay, but other than that, you should be on your way having a nice FreeNAS or whatever NAS system on FreeBSD powered hardware, or that's well supported driver-wise.
Yep. Anyway, if you're interested in turning one of these recycled Dell machines into a NAS, all the details are in the article here.
So, time for the Beastie Bits this week, starting with Adrian de Groot's post, FOSDEM blog post. So, FOSDEM's been a while, 2 months almost, or even more than that.
But I found the story while reading the previous update about KDE 5, because Adrian de Groot's a KDE developer who works on keeping it ported to FreeBSD, and happened to be at FOSDEM and came to the Dev Summit and so on. But he has a bit of a report on mostly KDE-related stuff from FOSDEM, including getting to play with his older KDE Slimbook and looking at a newer KDE Slimbook 2.
Oh, no, looks nice, yeah. With some more decorations on it.
Talking to various people where he was helping run the KDE booth and all the other interesting stuff that happens.
Yeah, FOSDEM is just great. I mean, not literally, but figuratively, it's a big conference, and there's a lot of open source projects that are popular or are just starting out. So it's definitely worth attending. You can get a glimpse of what it looks like from the pictures here.
Yep. But if you're more interested in the slightly less BSD focused and more desktop focused perspective on FOSDEM, check out that blog post.
Mm-hmm. Okay, next up is my first FreeNAS. And if you click on that, don't be shocked by the picture you see. This is not how you treat disks, unless you want to get rid of them. That certainly has lost data. It can't be recovered. I think not completely. So that one deals with creating a very first FreeNAS, which is interesting to read from someone who hasn't done this before, apparently. So it talks about...
The starting is like, since entering college, my file management has gone from tolerable to disgusting. My hard drives were littered with folders upon folders called sort me and so on, and lots of duplicates and so on. And they talk a bit about looking into it and then getting an IBM DS3200 and replacing it with FreeNAS.
Ah, yes, and it talks about the configuration.
So this seems to be one of the few people who used FreeNAS at work and then adopted it at home instead of the usual path, which is to use it at home and then end up solving problems with it at work.
Yeah, but we like either direction. So as long as people are using a good NAS solution, then they will see the benefits, definitely.
So the conclusion at the end was, my new FreeNAS server has been configured and I've been using it without error since. Shout out to the FreeNAS team, as they have great forums and lots of information. Again, I was not being very technical on purpose, as I wanted to give an overview of what FreeNAS is as a whole. And if you want me to add more technical details, then let him know in the comments.
Mm-hmm. Very good. And we're on the subject of NASes. NASes need disks, and disks need to be checked with Smart, of course. And we have a Smart call for testing by Michael Dexter, which ties into his last year's Asia BSDCon, which are now available on video on YouTube. We covered this last week. So he's talked there about Smart and making it more open sourcey.
So this is actually adding a Smart command to the BSDs. So currently, if you want to access Smart data on your drive, you're most likely using SmartMon tools, which is this GPL licensed tool, which you can package and install. But if you've ever tried to use it in a script or something, you might notice the output is not exactly friendly to anything but humans, and even barely humans, because of the way it tries to line up the columns and so on. So this is a simple, script-friendly Smart utility that is BSD licensed and could be, say, included in the base system once it's stable. Mm-hmm. So in order to get to that point, on FreeBSD machines, if you could run package install Smart and run Smart on a disk and make sure it works and point out any problems that don't work, especially if you have SSDs. SSDs do all kinds of weird things with Smart data and have a lot of different values that aren't common across hard drives. Mm-hmm. Or if you have uncommon hard drive manufacturer. We've got lots of Western Digitals and Seagates and probably HDSTs, but Toshiba's maybe less. And, any drives I don't have pretty much not been tested with this yet.
Yeah, I have a bunch of Intels. What are those?
So I have most of my SSDs are Intels. But if you have some of the more exotic...
Spinning Rust?
User grade SSDs instead of data center grade, the consumer class stuff. I've not tried any of things like that. I don't have any OCZ or
some of the older ones,
or any of these other more consumer brand SSDs, and we'd love to get more information about those.
Mm-hmm. And they provide
the source
instructions
code's up on GitHub, so if you want to try to fix problems, then go ahead. But if you do encounter a problem, they specifically ask for certain information, such as getting the list of devices as they're detected by FreeBSD, the identify information from the particular drive, and the output of the GPL Smart tool so that they can compare and figure out what they might be missing.
Yeah, help that effort, and it benefits everyone who's trying to check their
Yes,
disks.
because this should mean in time for, say, FreeBSD 12, we'll just have a smart tool built in instead of depending on smart CTL.
Mhm.
And
Very nice.
if it has output that I could say, if I could libucl it and make it, or libzo it and make it output JSON, that would be great.
Yeah, that tool will definitely get more functionality over time.
Mm-hmm.
Where such functionality is discussed typically is BSD CAN, and
Yes,
for that,
this is the main North American BSD conference and one of the biggest BSD conferences in the world. Most important event on the calendar. Highly recommend you attend.
yeah, be there, don't miss anything. And if you have a little problem financially, but definitely want to go, then the FreeBSD Foundation has put out their travel grant applications for BSD CAN now. So you have here a little small section in FreeBSD Foundation's blog that the travel grant application for BSD CAN 2018 is open now. The foundation can help you, yes, you, to attend BSD CAN through our travel grant program. Travel grants are available to FreeBSD developers and advocates, so you don't necessarily have to have a commitment. If you've been advocating FreeBSD in your circles, then you're definitely eligible for such a grant. Who need assistance with travel expenses for attending the conferences related to FreeBSD development? Then that travel grant period, you can apply until April 30. And you should apply as early as possible so we can decide as soon as possible and let you know.
Yes, because if you book flights sooner, they're cheaper.
Yes, and don't go, yeah, I don't contribute that much yet, and I'm not sure. Just submit the one. The worst thing that can happen is that we say no and you haven't lost anything. But if we say yes, you can go, you get that grant for a little trip report afterwards, then yeah, that's the thing. Then you'll be at BSD CAN 2018. So fill out the
I hope to see you all there.
Yeah, if it wasn't for the travel grant, then yeah, we can't help you only in this way. This is just
So
one
now
way.
for something completely different.
Yeah, switching gears here a little bit.
So BSD developer Christoph Stronson, who's we've interviewed before and worked on Mandoc and Beaches, and I think he did.
Was it Asia BSD Con this year?
Yeah, he was, but worked on the OpenBSD Acme client. I think that was his.
Yep.
Bunch of other things
Among
like
other
that.
things.
Mostly Mandoc, which has made all of our lives better in BSD and Illumos. Happens to be quite a deep sea diving aficionado. So he did an interesting interview with none other than Linus Torvalds, in which they did not discuss operating systems. So it turns out Linus is also a diver, and this is an interesting interview by Christoph's of Linus about diving and how that came about.
See, we can all get along underwater. Yeah, oh wow, this is very diving specific. I'm not that into diving, but oh wow, the pictures are nice. Look at that octopus. Cool. Oh wow, this is a really long interview or a long blog post.
Yeah.
Cool. See?
And it gets into some open source diving software that Linus has written called Subsurface.
He couldn't call it subversion because, yeah, then it would be.
Well, also because that wouldn't be about diving.
Oh, great. Yeah. Here go the puns again. Yeah, so check out that one and yeah, see how maybe that tool, if you're a diver, then maybe that tool will help you.
Yes. And, if you're interested, also check out the rest of Christoph's blog, including, I think the front page has a map of all the different places he's done his diving.
So the next item is from Michael Dexter's Twitter feed, and he asked on a semi-official or semi-serious Twitter, I think it's serious enough, Twitter vote, the secret to a faster FreeBSD default build world is, and he provided a couple of options with a follow-up response to himself with a couple more options, and 48 votes were cast during the voting period, and 13 on the sub voting section, and 48%, and the winner was TempFS on user source and user object, followed by 40% more hardware CPUs, and with just 8% more virtual CPUs and 4% more gigahertz. And the compiler cache received 54% of the votes, and more RAM received 46% of the votes. That's interesting. So they're different.
I think
combine those.
Early testing showed that the first 4 hardware cores make the biggest difference, and then sometimes you end up blocked and waiting on other stuff, and you don't quite get a linear progression anymore after 4. But
yeah, don't try to rebuild stuff that's already new or has the same way or has the same binaries that you already
watch
have.
Out
so
for NUMA. In particular, if you have Ryzen, you may have 16 cores, but what you actually have is 4 separate CPUs with 4 cores each, and talking between them can be more expensive and cause interesting side effects. Same thing with, he was comparing a 4-core E5 1620 to a dual E5 2670. So 2 separate sockets made a big difference there. Oh, and he actually another one here with 4 E7 4870s, which is a really big machine.
Yeah, certainly. A lot of CPUs.
I'd like to have one of those. I wouldn't like to pay for the electricity, though.
Okay, yeah, so I just thought we shared this with you to see, for people who are still wondering how to speed that up. So, and the last bit that we have is one I found just recently. It's called Teammate, which is an instant terminal sharing application using Tmux, of course. And if you're doing a lot of demos or showing other people how certain things are being done or how you do them in the shell, this is something you should look at, because it allows you to share a read-only view of your terminal, among other things. And the read-only connection string can be retrieved with Teammate show messages. And so basically another person can run this, and you can run this as a server so other people can connect to that and watch what you're typing. And this is good for demonstration purposes, or I need to enter a couple of complicated commands and someone else should check over that and contact me if I'm doing something wrong. Or maybe Alan wants to show me how to configure a certain ZFS pool configuration.
Right. So in FreeBSD, there's a tool called Watch, which is designed for root to watch somebody else's terminal. So you can, basically someone else SSH in, and you can use Watch to then have a read-only view of their session, but there's a flag to make a write view to their session as well, which basically can end up doing the same thing, although I definitely see the advantage of Teammate in that neither of these people have to be root for this to work, and the other person doesn't need an account on the machine and so on. But I found Watch particularly useful during training, teaching people stuff, mostly for one-on-one, obviously, but have them do it in their terminal, but I'm connected with usually the right option, and then I can basically watch what they do and see how they're doing it, and add things, or when they try it and it doesn't work, I can show them you forgot this bit, and so on. And just having my own keyboard, sharing keyboards with people is not fun.
Yeah.
It can also help. I found some people are nervous typers. They type a lot slower if somebody's watching them.
Yeah, that's true. Yeah, if you watch over their shoulders.
I had not experienced that. I've never felt this myself. So I found it very strange when the first time I'm like, you type faster when I'm not looking. What's up with that?
Yeah, or they make more typing errors because...
Yeah, and I'm like... Sorry, I will not hover. So using something like this, so
Pretend I'm
that
not here.
I'm hovering, but they don't feel me hovering. It speeds things up a lot.
Sure. So there is a bunch of ways you can install this for various operating systems provided on the website. And there's a little architecture diagram as well if you want to get into the technical details. Otherwise, just try it out. Another thing you should try out is our feedback and questions sponsor, Tarsnap, of course, because you can never have enough backups, and that's one way of doing them. But the paranoid
Because
way,
you can never have enough backups, but if they're deduplicated, you don't have to pay for all of it.
exactly, yeah. You might have a bunch of files that you need to back up just in case something goes wrong, like SSH keys or other access data, and you want to make sure.
The number of people who like lose their SSH key every time they change computers or something. I'm like, yes, it's good to refresh your SSH keys when you get a new computer, but you probably don't want to do it because you have to because you lost the key.
Yeah.
Right? So back it up and then have the old keys so that you can go in and cycle the keys yourself instead of needing somebody else's help. Or, whatever
All
data
kinds of
it
ways.
is, don't lose stuff. Nice thing with Tarsnap, every backup is a full backup. But because of the deduplication and compression, you're not uploading all your data every time. But it means when it comes time to restore, it's just restoring one backup. You don't have to restore the full and then apply a differential and then like 3 incrementals to get back to the latest version of your files.
That's very nice. And if you know how to use tar, then it's basically the way you use tarsnap because it's basically using the same syntax. And if you are the only person holding the key, you should keep that one key separate and secure. Then you are the only person who can access those encrypted files.
Yep. There's a convenient way to print the key out and you can laminate it or whatever. It has check digits set up so that you can OCR, or even if you type it out, it can tell you which lines you made the typo on. So you're not retyping a blob of text like this and then realizing there's a mistake somewhere in it.
Just start over. No, not with tarsnap. It shows you which line, which
hey, this
which
line
character.
This line doesn't match the checksum at the end. And you're like, oh, okay. And yep, there's the mistake. Fix it and get your key in there.
Yeah, they have also man pages, of course, and a bunch of other documentation, as well as a book, Tarsnap Mastery, written by Michael W. Lucas. So
and
all
the
good
source
reasons.
code, the source code is there. No other backup tool or no other online backup service gives you the source code for the tools. That's why
because they're
Tarsnap is the only one you can trust. It only costs $5 to get started. You might as well give it a try. Once you give it a try, you're probably going to stick with it. I have.
Yeah, if you like it, then definitely use it. All right, time for our feedback and questions section for this week. We're getting a bit low on feedback that we received, so make sure to send us.
We're doing double episodes 2 weeks in a row to cover my trips to
travel.
the ZFS user conference and then Linux Fest Northwest. And then we'll be back for a couple of weeks, and then we have to do another double to cover Benedict is going to a NetWays something.
Yeah, I'm for a training that I'm doing for 3 days, Isinga fundamentals, which is nice.
Right.
I look forward to that.
So all of your emails are super helpful to keep this section of the show going, especially since we lean on it a bit heavier when we have to come up with 2 weeks worth of news in 1 week, and especially when we have to come up with 2 weeks worth of news in 1 week, 2 weeks in a row, which is basically a month worth of news in like 8 days.
Sure. Well, we could do another round of viewer interview questions.
Yes, if you have more questions, please send those in as well. You would. I know a lot of you would like to get to know us better, or just understand things.
Why are we doing this? Why are we here? Things like that.
Yes. So if you have viewer interview questions, make sure you put that in the subject so we can sort them out. But feedback at bsdnow.tv and ask us your BSD questions, and we'll answer them during the feedback section. Or if we get enough viewer questions, we will interview ourselves again. We're also working on a couple of interviews we're trying to get soon, and lots of good stuff coming there as well. But if you know someone who you have some leverage over to make them give us an interview, definitely hook us up. Let us know. feedback@bsdnow.tv.
Excellent. So after this small section here, we start with Vcache about getting a port added. So that goes. Hello, Alan and Benedict. Thanks for the great shows. Thank you. How do I get a port added to the ports tree is the question. I've logged a bug with a bug number here back in 2016, and I've updated the port version since after I've tested it in my environment. Is the waiting period always this long? I'd like to contribute more ports that I will maintain, but if I can't get a port added after 16 months, then it's really worth the effort. Let's look at that bug here.
Yeah, so I looked at I see it's been classified recently. The hardest part is, there are literally tens of thousands of these bugs, and the contributors don't always find your particular one. So sometimes it helps to know a couple of ports people to get in touch. So I've tagged 2 ports committers on your bug there to hopefully get some attention. And if you work with them on 1 or 2, then you'll very quickly get to the point where you'll have attention. It's mostly just the fact that we don't have enough committers in order to help all the contributors become committers.
Exactly, yeah.
And because of that, a lot of contributors end up not becoming committers. It is a catch-22 and a problem we do need to solve. I just don't know how we solve it. But hopefully we solve it by getting attention on your bug, getting those set up, getting you maintaining a whole bunch of ports, get you a ports commit pit, and then get you searching the bug database for other people like you who feel abandoned and helping them out, and on and on and on.
Yeah.
And the vicious circle of turning everybody into a ports committer.
Exactly. I mean, if people submit something, there's maybe 50 other people who submit something as well, and it gets pushed down. But it's like in your inbox where a message gets pushed down, and you don't, you lose track of that. But it shouldn't be an excuse to totally ignore that bug. So
yes,
sorry for that, and we hope to get that.
Time. Yes. In particular, because your thing has to do with Logstash, I tagged Dan because I know he works a bunch with that at his day job. So maybe that will help inspire him to be interested in your report, and that is actually useful to him as well. And then Joseph McGrone has been my go-to ports person lately because if I point him at something, he usually makes something happen out of it. I feel bad for abusing him. I was nice to him once many years ago, and he's been nice to me ever since, and I maybe lean on him a little too much. It's like, it'd be really helpful if there was a port of this. Hey, Joseph, I need a port of this. And then boom, it's done. Like, you're the best. I'll have to buy him dinner at BSD Can or something to make up for my abusing him a little bit.
Okay, yeah. So definitely send more ports if you really like working with that, and we hope to integrate them as fast as possible. Okay, thanks for that feedback. Next up is Chris with Quarterly Ports Branch. So that goes like this. Well, I need to open that first. I accidentally opened it wrong.
Come on.
No, I had opened one twice, so that's wrong. So here it goes. Hi, Alan and Benedict, and JT, if you're reading. Thanks for the great show. This is a long email, so feel free to split it up or omit certain parts. Okay, let's see. Thanks for the feedback. On episode 230, Jason asked about broken ports resulting from the default configuration of tracking head for the ports tree and the quarterly branch for packages. He posted about that last year, along with the script making it easy to use the quarterly branch for ports. So here's a link to that article.
That somehow fell off my to-do list. I asked Colin about it, I think last year or 2 years ago at BSD Can, about making port snap versions of the quarterly branch and making it easy to, in your portsnap.conf, have it download the quarterly branch and possibly even just make that the default so it matches what package does on releases and different on head. But it's nice that you have a script here for that people can use in the meantime.
Yeah, it looks good. I know a lot of FreeBSD people watch this blog, or not just this blog, but this episode, and maybe they can take a look. That might be a good thing. So that will give you probably some people looking at that and contacting you maybe. The second question is, I'm about to start a new project at work where I'll have an influence on the continuous integration, continuous delivery / hosting infrastructure. So I'd like to recommend FreeBSD if it fits. I've managed FreeBSD on my desktop and individual servers for years, but never a cluster. I'd need to provide an environment as easy and scalable as Docker containers managed by Kubernetes on AWS, but Docker didn't seem to be production ready on FreeBSD the last time I tried it. Any input or pointers to reference?
The configuration for the Jenkins cluster stuff on FreeBSD is on the GitHub, like in the FreeBSD organization.
Yeah, and there's also more information on the FreeBSD wiki about Docker. It's not an official document.
Docker is not production ready on FreeBSD, but you don't have to do something that way in order to,
there's a bunch of instructions already there. You can try it. Maybe that's already sufficient. I guess for the CI stuff, you only need to build.
Docker's not ready to use. I just said that.
Yeah, true. Maybe you can replace that with jails because they're isolated as...
It depends what you're doing, but with your CI stuff, you generally don't need something that you throw away every 2 minutes, like with the Docker. And so it can be set up pretty straightforward. But I've added the link to the show notes with the link to the repo where we have all the configuration and the wiki page for how Jenkins, the CI/CD stuff is run on FreeBSD for the official FreeBSD stuff, and maybe that'll help you get started.
Yeah, and on a related note, I thought you mentioned that the FreeBSD CI/CD team was looking for help, but I can't find the details in a recent episode notes. Could you please point me to the notes or links so that I can see if it's something I could help with when work slows down a bit? So I recommend contacting...
is just email jenkins-admin@freebsd.org and ask them.
Yep,
there's also the FreeBSD-CI channel on EFNet. Both of those are linked in the wiki page, which I've added to today's show notes as well.
Mm-hmm. Yeah, there's the team to contact, and they will certainly be happy to get some help. And so good luck with your project at work. Maybe we can cover it in the future if you have made some progress there. It would be interesting for other people to see how you can build a FreeBSD CI/CD server in interesting ways. Because this is basically something that you need nowadays to run your tests and deployment infrastructure. So yeah, good to have. So nice that you tried it FreeBSD. Mm-hmm. And last but not least is Gordon about centralized storage suggestions. So that one goes, Dear Alan and Benedict, I wonder if you're able to offer any suggestion regarding a centralized storage solution for fairly large files, typically up to several gigabytes. I look after a number of offices within a marketing group. The offices are relatively small, ranging from around 8 staff to 150 staff. Wow. Each office works with a lot of documents, presentations, and media files. Why am I not surprised? So the storage requirements can be quite high relative to the headcount. Unfortunately, also the budget. Typically, though the files are only used regularly for a short length of time during a project, but also kept indefinitely in case they need to be referred back to. I have always ruled our centralized storage due to latency and speed on internet connections, but now, as all offices are on either 10 megabits per second or 1 gigabit per second, symmetrical
that was
connections...
100 megabits or 1 gigabit. There's a big difference there.
So, oops, I admitted that. Sorry about that. So he feels that it is time to revisit the possibility of centralizing storage. This would bring greater cost savings and would simplify backups a great deal. In particular, he's interested in some sort of local caching storage gateway, perhaps like the AWS storage gateway, which presents a local view of all the office's files on the centralized storage, but only keeps a cache of the most recent files, and anything not in the cache would be pulled from the central storage. This would have to present as server message block or Samba or Apple File Protocol locally to the workstations. We use FreeNAS for a lot of our deployments, both centrally and within some remote offices. So obviously something involving ZFS would be ideal. Yes, I'd say that. Are you aware of any projects that might fit my requirements?
So yes, I would definitely say ZFS for the central thing. And then for the nodes in the office, what you really want, yes, is some kind of like transparent Samba proxy. I don't know how to get smart caching for that.
Yeah, it would be some kind of synchronization solution.
Well, yeah, but synchronization is not the same thing as caching. Like, if your data set was small enough that you could keep a copy on every one of the FreeNASes, that's one thing.
Yeah.
But it's more likely what you really want is
some
cache
kind of
of
document store.
only files that have been modified this week on each FreeNAS or something, or on at each office, and then the big central FreeNAS somewhere in a data center or whatever. I know that Panzura makes a product based on this that's FreeBSD and ZFS. They have a very complicated setup where, so in the ZFS block pointer, there's the 3 slots for the up to the 3 copies, and it's basically addresses of the where it is on your VDEVs. Except for in the Panzura version, the third one refers to the cloud or the central storage, basically. And so copies of files can exist locally and in the cloud at the same time or whatever. Anyway, but I think the metadata for everything is always everywhere. I'm not entirely sure how that works. Anyway, I'm not aware of anything that would do the caching quite like that, but that'd be really nice. Almost like a... I don't know if you'd want to do that like as an add-on to Samba or try to do it underneath Samba. Because in particular, what you'd really like is read-ahead type of thing. So if Samba's trying to read, a file that doesn't exist on the local node, it will pull it from the remote node, but it will read ahead some reasonable amount so that hopefully then when this request for the next chunk comes from Samba, it's already arrived.
Yeah, so it would be... Doesn't FreeNAS have something like that? Because I think that's a problem they also have to deal with in a larger scale.
There's not really any sort of clustered solution for ZFS. Because you probably don't actually want a cluster anyway. Caching is a very different approach.
Maybe some of our viewer knows.
Like an L3 cache for L3 ARC for ZFS, which caches stuff that actually exists somewhere else. But that'd be a lot to build. I don't know a solution. Maybe somebody else does.
Yeah. Send this to us along with your other comments, questions, and we'll link you up with Gordon to connect you. All right. But anyway, thanks for the question.
Remember to send us your questions, feedback@bsdnow.tv. That's feedback@bsdnow.tv. I'm just going to sit here and keep saying that until you send us an email.
Please stop.
feedback@bsdnow.tv. Anyway, we will see you next week. And if you're watching, remember, we're also recording an extra episode on April 6th. So if you happen to be around at 2 o'clock Eastern, which is, 6 p.m. UTC, hop on the live stream and join the IRC channel and, participate in the live show.
Yeah, where everything can happen from bloopers to me messing up the English language. Thanks for watching and see you next time.